Hi students, welcome on STEM with the DK Swami. So in today's lecture, we are going to talk about the bimetallic strip. So like here we have the two rods of different materials. They have been attached like this with uh, each other like this of length L and L, this one and this one. And each of the rod is having a thickness of D, and they are attached, they are joined here. Okay, and they have the different coefficient of expansion alpha 1 and alpha 2. Now if the delta T temperature is increased for both of them, let's take alpha 1 is more and alpha 2 is less, then think about it. What will happen is that the first one is going to expand more. It will try to expand compared to the second one. The expansion in the first one is going to be more because the coefficient of expansion of the first one is more. I'm taking this condition. Okay, so that's why to adjust with this expansion, the first one and second one, they will bend like this, and then they will form a arc right here like I have shown you here. They will form a arc like this. In that arc, the material which is having more coefficient of expansion, that material will be toward the convex side, and the material which has lesser coefficient of expansion, that will be towards the concave side, because the material which is toward the concave side has the lesser length of the radius of curvature. That is why for the same angle, the length of the arc is going to be lesser. But for the radius, for the material which is toward the convex side, that has more radius of curvature, and for the same length, same angle of arc, the length of arc will be more. So now in this bimetallic strip, here we want to find out what will be the radius of curvature. What is the final radius of curvature R? Basically, I want to, of course, both of the materials have the different radius of curvature. Just for the joint, I want to find out what is the mean radius of curvature R. I want to find out that. Where do we use this bimetallic strip? This bimetallic strip is used for the circuits where we want to join the circuit, or we want to break the circuit at certain temperature. Okay, think about it. Let's suppose we have a material like this. Okay, right now at T temperature, we have something attached it like this to some wall, and here there is some circuit. Right now it is disconnected. When I increase this temperature, so then this radius is going to decrease, and because of that it is going to attach like this. Length will expand and then it will attach like this. So then the circuit will start working like this. It can also happen for the breaking of circuit. All right, so here I have taken these two materials, length is L. Let's suppose for the first material, this first material, the radius of curvature is R plus D by 2, right? Okay, so R plus D by 2 times of, let's suppose the angle right now, this angle is theta. That is the length right now, L1 let's call it. That length is the total length at delta T temperature. Can I say that length according to the thermal expansion, the length at delta T temperature is L1 plus alpha 1 delta T. Why I'm saying R plus D by 2? Because this mean point radius is R, and from here I'm going at a distance of D by 2. Same way if I go here, this is R, and then if I go inside, so then the radius from this point, this radius of curvature is going to be R minus D by 2. So R minus D by 2 times of theta is going to be length 2, and that is L1 plus alpha 2 times of delta T. This will get. Our purpose of this calculation is to find out the radius of curvature. That is why I am dividing these two sides. When I divide, theta and theta will be cancelled out, L and L will be cancelled out, and then I will get that R plus D by 2 divided by R minus D by 2 is equal to 1 plus alpha 1 delta T divided by 1 plus alpha 2 delta T. When I cross multiply, so then I will get R plus D by 2. I am multiplying this term with this term. Okay, and then if you multiply alpha 2 delta t, so then we'll get r alpha 2 delta t plus d by 2 alpha 2 delta t, and this side will get 1 plus alpha 1 delta t, and when this one sorry, let me correct it, this side will get first r minus d by 2 will be multiplied with 1, so that is r minus d by 2, and then they will be multiplied with the alpha 1, so then r alpha 1 delta t and minus d by 2 alpha 1 delta t. Now here this term will be cancelled out, this term and this term will be cancelled out. Why? Because this d by d is very small and alpha 1 and alpha 2 is very small, so that is why comparatively we can take it negligible. So this term and this term I am cancelling it. Second is r and r is cancelled out here. Okay, and here we have the r1 alpha 1 delta t, and here this side we have r alpha 2 delta t. So what I am doing is I am writing down this right hand side to the left hand side. So I have r plus r times of alpha 1 delta t is minus d by 2 is equal to d by 2 plus r times of alpha 2 delta t. And then if you bring this term this side and if I send this term that side, so then I can write down r delta t, I can take out common. Then here I have alpha 1 minus alpha 2 is equals to d. So then the r is going to be, because d by 2 plus d by 2 will become d, so r will become d divided by alpha 1 minus alpha 2 times of delta t. Okay, this is how we get this radius of curvature. Right now this would be the radius of curvature. Here we have taken a approximation, this we have taken it as negligible. Sometimes this formula we can directly use in the competitive exams to find out the radius of curvature. So this is our bimetallic strip. Hope you understood this concept of the bimetallic strip. Where do we use it, how do we find out the radius of curvature, and how this thermal expansion is going to play the role. Now you can even think about trimetallic strip. What is going to happen if you arrange them in increasing order, decreasing order, and maybe some other way. And then you can also think about this another kind of rod. Let's suppose you have one material like this, the other material like this, you join them and then you increase the temperature. All of these, if you think, then you will find it very interesting, and like this your mind will also be engaged in this topic. And there are the other videos available on the channel, you can go through them and of course you will find them interesting. You can also share these videos with your friends if you find them interesting. Thank you very much.